This question is, of all the closed cylindrical cans of a given volume of 100 cubic centimeters, find the dimension of the can which has the minimum surface area. Okay. So there is a cylindrical can, right? So for this cylindrical can, what is fixed? The volume is 100 cubic centimeter or 100 cc, right? But the volume is fixed. So what do you think are the parameters that can change? Obviously, it is going to be the radius and the height. The radius and height will get adjusted in such a way that the volume of this cylinder is always going to be a constant. So volume is equal to how much? Pi r square h. And how much is this value? It is 100 units. That is centimeter cube, right? For this kind of a surface, right? For this kind of a shape, if you are describing the surface area, so when they say the surface area, right, it is always the total surface area. If it is curved surface area, they will be specific in the problem. If they say only surface area, then I'll call the surface area to be S. So what is going to be the surface area of a cylinder? You have two circles. So area of each circle is pi r square. So it is going to be 2 pi r square plus pi r square. It is 2 pi r h. It is 2 pi r h. So 2 pi r is the circumference multiplied with the height is going to give you the curved surface area, right? So what can you take out common from this? You can take out 2 pi r common and you can write it as r plus h. Let this be equation number 2. If you observe, the function which we need to frame in this question is the surface area, right? What is expected to be minimum? The surface area is expected to be minimum, right? But if you see, surface area is a function of two parameters. Why did I say they are parameters? They are variables. What are the two variables here? Radius and height. Because I don't know what is r, what is h. None of them is fixed, right? So where can I get the value from? From the first equation, obviously. So from 1, if I observe, I can write h is equal to 100 divided by pi r square. Let me call this as 3 and I'll take 3 and substitute it in 2. Right? When I take 3 and substitute it in 2, S will be equal to 2 pi r into r plus 100 by pi r square. Okay, now actually you can open it up. So it is going to be 2 pi r square plus 2 pi into 100. So pi and pi will get cancelled. 2 into 100. 200 divided by, you will get r divided by r square. It will be 200 by r. So the surface area is actually a function of this sort, which is 2 pi r square plus 200 divided by r. Am I clear? Right. Now, what are we supposed to do? So since S is a function of r, S dash of r should be equal to 0. So what is S dash of r? It is going to be 4 pi r minus 200 divided by r square is equal to 0. Correct. So which implies r cube is equal to, this 4 will cancel this 200 50 times. So it is going to be 50 by pi, which implies r is equal to 50 by pi, the whole power 1 by 3. So this is going to be the radius at which the surface area is expected to be minimum, but we didn't do the minimum test yet. What is the minimum test we need to do? Take the double derivative, substitute this value. The second derivative should be greater than 0. Okay. So we'll do the test also. So S dash is equal to 4 pi r minus 200 by r square. So S dash is equal to 4 pi r minus 200 divided by r square. So what is going to be the value of S double dash? It will be 4 pi minus 200 into what is the value of r power, what is the derivative of r power minus 2? It is minus 2 into r power minus 4. So how much is it? It is minus 2 into r power, not minus 4, it is minus 3. So minus 2 into r power minus 3. So it will be minus 2 divided by r cube. So what will happen? It will be 4 pi plus 400 divided by r cube. You need not substitute the value at all. By looking at this expression, you can say it is positive. Why? 4 pi is positive, r is positive. Substitute sum of two positive numbers is greater than 0. So for r is equal to 50 by pi the whole power 1 by 3, it is going to have minimum value. Which is going to be minimum? Surface area. Which surface area? The total surface area. Okay. Having said this, what did they ask? Find the dimensions of the can which has the minimum surface area. Among the dimensions, r is equal to this value. Let me call it as 4. Right. Take the fourth one and substitute it in the third one. Right. So what is h? H is 100 by pi r square. I'll write it here. H is equal to 100 by pi r square and r is equal to 50 by pi the whole power 1 by 3. Take this and substitute it here. H will be equal to 100 divided by pi into r is 50 by pi the whole power 1 by 3 the whole square, which is going to be 2 by 3. Right. So it will be 100 divided by 50 power 2 by 3 into pi by pi power 2 by 3, which is going to be pi power 1 by 3. Okay, listen to this carefully. 100 can be written as 2 into 50. So I'll leave 2 as it is. 2 into 50 divided by 50 power 2 by 3 into 1 by pi power 1 by 3. So 50 by 50 power 2 by 3 is going to be 50 power 1 by 3. So this will become 50 power 1 by 3. This is pi power 1 by 3. So combining both, you will have 50 divided by pi power 1 by 3. So to put it simple, r and h are double of each other, meaning h is equal to 2r. Okay, they have the ratio of 1:2 or 2:1 depending on which one you take first. So h is equal to 2r. Suppose the same problem is given in some other format, you can have this in your mind. So what is the conclusion we can draw from this is, whenever you have a closed cylindrical can of a given volume, need not be 100 centimeter cube, of a given volume, then they ask you to find the dimensions of the cylinder which has the minimum surface area. Then the relation that you will always get established is the height will be equal to twice the radius. Okay, this is a relation that we will get. But in this problem, since 100 was mentioned, we got the specific values. What are the specific values? R is equal to, so R is equal to 50 by pi power 1 by 3 and H is equal to 2 into 50 by 3 power, 50 by pi power 1 by 3. Okay, you can make a note of this. Now, they need to explore in minus. So minus 2 into explore minus 2 minus 1 minus 2. Okay. So listen. The next question is, a wire of length 28 meter is cut into two pieces. One of the pieces is to be made into a square and the other into a circle, right? What should be the length of two pieces so that the combined area of the square and the circle is minimum? So what do we have basically? We have a wire of length how much? 28 meter. Now this is cut into two parts, right? It is cut into two parts so that the first part, okay, is bent in the form of a square. And the second part is bent in the form of a circle, right? So the square has an area, circle has an area, okay, accepted. Now what is their expectation? That the sum of the combined area of the square and the circle put together should be minimum, right? How to approach this? So here if you observe, the parameter that is constant is the total length of the wire, right? So if I take the length of the wire that is used for the circle to be L, then the length of the wire that is used for the square is 28 minus L. Make sense? See, this length, if I call it as L, then the length that is utilized for the square is 28 minus L. Okay. Now tell me one thing. This 28 minus L put together should be equal to whom? Should be equal to the perimeter, should be equal to the perimeter of square. Right? What is the perimeter of square here? It is going to be 4a. So a will be equal to 7 minus L by 4. So it is going to be 7 minus L by 4 because 28 minus L is equal to 4a. So a will be equal to, bring this 4 this side, it will be 7 minus L by 4. Right? So a will be 7 minus L by 4. Let this be equation number 1. Right? And what about the circle? The length of the circle should be equal to the circumference of the length L should be equal to the circumference of the circle, which is going to be 2 pi r, which implies r is equal to how much? L divided by 2 pi. Let this be equation number 2. Now, what is going to be the area of the square? So, square area is going to be a square, which is 7 minus L by 4 the whole square. Then what is going to be the circle's area? So circle's area is going to be pi r square. So pi into L square divided by 4 pi square. So when you add these two, you are going to get the combined area. Let me call that combined area to be A. There is no space. Yeah. So let me call that combined area to be A. Combined area is going to be 7 minus L divided by 4 the whole square plus pi into r square. What is r square? So L square by 4 pi square. So pi into L square by 4 pi square. So area is a function of one variable. What is it? It is a function of length. So differentiate, solve it, you will get the answer. So what is the value of A dash? A dash will be equal to 2 into 7 minus L by 4 into derivative of 7 minus L by 4 is minus 1 by 4. So here A dash means derivative of A with respect to capital L. So into minus 1 by 4 plus pi by 4 pi square into 2L. Okay. So 2 will cancel this 4 twice. The answer will be 7 by 2 minus 7 by 2 plus L by 8. Minus 7 by 2 plus L by 8. 2 will cancel this 4 2 times. So this is going to be plus pi L divided by 2 pi square. Right. So pi and pi will get cancelled here. So this value should be equal to 0. From this, find out the value and find out the value of L and tell me. Then we'll find the second derivative of A. Okay. So copy it. Done. Tell me what is the value of L? Hey, everybody is tired. School, they're torturing you. Huh? Simply yawning. No, ஒன்றும் இல்லையா ஒன்றும் மெயினாக ஒன்று தான் பார்த்தேன் சிரிக்காது what is happening? அதனால டென்ஷன் நான் முடிச்சிட்டேன்ல அப்புறம் உனக்கு என்ன பிரச்சனை Others should be worried. I completed and I am in advance. Why are you worried about it? Here, what is the value of L? By 5 plus 1. Maybe. Anybody else with the same answer 28 divided by 5 plus 1? Problem number 20. 5 plus 4 1. And see, if it is the multiple, we get 4 then over 5 plus 4. LCM was definitely a 5 plus 1. Then you're wrong. Let me do it.
So is L is equal to 28 by pi plus 4?
You have 28, 5 plus 5 is the question is 7 by 2 goes to the other side. What is common here? Can I take out L by 2 common? From here, if I take L by 2 common, I'll have 1 by 4 plus 1 by 4 plus 1 by pi. Did you understand what I did? So I took L by 2 outside because the least number among 8 and 2 is 2. I took it out. So what is left out? 1 by 4 from this plus 1 by pi from this. Right. This minus 7 by 2 will go to the other side as plus 7 by 2. 2 and 2 are gone. Now this will be L into pi plus 4 divided by 4 pi. This is equal to 7. So L will be equal to 7 into 4 pi, which is going to be 28 pi divided by pi plus 4. So this is the length of the wire that is needed to make the circle. Then what is the length of the wire that is needed to make the square? So length of the wire needed to make the square is 28 minus L. So it is going to be 28 minus L is 28 pi divided by pi plus 4. So it is going to be 28 pi plus 28 into 4, 84 minus, I think it is 112. Correction. So it is going to be 28 pi plus 28 into 4 is 112 minus 28 pi, the whole divided by pi plus 4. So 28 pi and 28 pi are gone. Answer will be 112 divided by pi plus 4 is equal to the length of the wire that is needed to make the square. So this is the length needed to make the square. And this is the length that is needed to make the circle. So I hope it is clear. Right. See, this is also an important problem. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 times the volume of the sphere. Means if I have a sphere, right, in the sphere, if you need to inscribe a cone, right, volume of the largest cone. So like this, you can place many such cones, among which if you try to calculate the volume of the largest cone will be in such a way that its volume will be 8 by 27 times the volume of the sphere itself. Okay. So here, if I take this to be the radius, right? If I take it to be the radius and I take this to be small r. Is the point clear? So this is also going to be capital R, right? So from here, let me say that the height of the cone is small h. So I'm using small r and small h for cone, capital R for sphere. Okay. So when I do this, what I'm going to get is this will be h minus r. Am I clear with this? Right? I'm going to get h minus r. Now, what is going to be the volume of the cone? volume of cone is 1 by 3 pi small r square h. So volume of cone is dependent on two quantities. Both are variables, right? Now, what is the volume of sphere? It is 4 by 3 pi capital R cube. If you observe, they have given the radius of the sphere, meaning it is a constant. If the radius of the sphere is constant, volume of the sphere is also a constant. Now, what we need to do from here is, you need to find the relation between all the parameters. So my job is to eliminate R and write it in terms of H or H in terms of R, right? So what we can do is, if I take this to be OAB, if I take the right angle triangle OAB, what do I get? Capital R square will be equal to H minus capital R the whole square plus R square, which implies R square will be equal to capital R square minus H minus capital R the whole square. Is the point clear? So this will be capital R square minus of H square plus R square minus 2RH. So R square and R square are gone. So you will have 2 times RH minus H square. So let me take this as equation number 1, this as 2, and this will be 3. So what I will do is, I'll use the third equation in the first, because it is easier. No, I have direct expression for R square itself in terms of small h. Take and substitute it here, right? So what is the volume of cone? So I'll write it as VC. Okay, VC is equal to 1 by 3 pi into, in the place of R square, you will write it as 2RH minus H square into already available H. So what will you get? You will get 2 by 3 pi R H square minus 1 by 3 pi H cube. So this is going to be VC, which implies, what is going to be the value of VC dash? So here VC dash means you're differentiating the volume of cone with respect to small h, right? So this will be equal to 4 by 3 pi capital RH minus pi h square. Why I wrote it as pi h square is, you'll get 3h square, 3 and 3 will get cancelled. So if I equate this to 0, then I'll take the value of h outside, h into 4 by 3 pi r minus pi h is equal to 0. So pi will also get cancelled. So what will happen is, h should be equal to 0, right? What should happen? H should be 0, which is not possible. If h is equal to 0, there is no question of cone itself, right? Or else h should be equal to 4r by capital 3. Sorry, 4 times capital R by 3. It should be 4 times capital R divided by 3. Let me take this as 4. Now listen to this carefully. If I take 4 and substitute it in 3, right? If I take 4 and substitute it in 3, see what is going to happen. R square is how much? 2RH minus H square. But H is 4R by 3. Okay. So 2RH, 2 capital R, H is 4R by 3 minus H square, which is 16R square divided by 9. Okay, how much is this going to be? 8R square by 3 minus 16R square divided by 9. So multiply this with 3. So 24R square by 9. So you will have 8R square divided by 9. Let this be equation number 5. Now see, volume of cone is how much? 1 by 3 pi small r square h. So it is going to be 1 by 3 pi into small r square is how much? 8r square by 9 into what is the value of h? 4r by 3. So 3, 27, 81. You are going to get 32 by 81, right? 8 fours is 32. 32 by 81 pi r cube. Am I right? Right. Now, if you observe, if I take out 8 outside and if I take out 27 outside, 8 into 4 is going to be 32. 27 into 3 is going to be 81. 4 by 3 pi r cube. If you observe, this is going to be the volume of the sphere. So what is happening? When you want to define a cone that can be inscribed into a sphere where the cone's volume is supposed to be maximum, then it is possible when the volume of the cone is equal to 8 by 27 times the volume of the sphere. And that's what the question is. I hope you could understand, right? And mark it as very, very important, right? See, if you observe, right, I just want to stress on one point. If you observe, you're doing nothing much. Only thing is you need to decide on which variable you want to deal with. Here, why did I choose h? I could have written, see, if had I taken h, what would have been the complexity I would? Had I tried to write h in terms of small r, what would have been the complexity? H is, there is a quadratic equation in h, which would have been difficult for me to write it in terms of r. But r square, I have a direct expression which I can directly substitute it here. So that is the only point where your presence of mind should work. Okay, so be careful about it and you do that, except that this chapter is not that tough. Only thing is it is lengthy, I accept, but it is not tough. How many more are there? 4 more, I think, right? 6 more. These things are easier. 28, 29 is also easy. So only thing is these statement-based problems alone, we need 24, 25, 26. Okay, those things need to be solved, right? I don't think we can solve another problem. Okay, that is 15 to 20 minutes. Let's stop with this. And officially confirm, I'll be closing this chapter, not be doing those problems. Time for the record and review this. Or is the whatever it is. Next week, and this starting the last chapter of this book is, and this is a just need to operate with numbers. It's simple only. So those were exams you will not be able to make it in the class. So you can go through the recording. But others, because really students don't know that they have any class. Okay. But others will require. I'm not sure if the start of the school or not. So better. That you even see maximum 4 classes, 4 to 5. Better is it. Kedra? And I'm going to go to the program of 10 days. Better exam. But dedicating inverse function and ask you to reach inverse trigonometry. Okay, so those are online. Hope you could understand.
Yes, sir.
Okay, so I hope you could hear also. So I'll not be doing the remaining problems. Remaining you have to try it on your own. If you have any doubts, you can reach out. If time
Yes, sir.
permits, I'll record them and give it to you. You can have a look at it.
Okay, sir.
Okay, sir.
So we
Thank you,
can,
sir.
yeah.
Sir, in relations and functions lesson, I have a doubt, sir.
So
Sir, for transitive, is there any concept like vacuously transitive and the Mary, sir?
that is there, but generally we don't discuss it in NCR. So we'll assume that they teach it in school.
Ah,